Okay, here's a problem that I want to work. It says to determine the acceleration of this cabinet and the normal reactions under the legs, and they give me a force P and coefficients of friction, etc. Now, it's not clear to me if this thing actually slides or tips or what it does. Now you can maybe guess, but what I'm going to do is I'm going to use the technique and say, I don't really know what it's going to do. So here's what I want to do. I want to make the problem a little bit more interesting. I'm going to say that I'm going to let this be a distance d, and I'm going to adjust the value of p. So in other words, I'm going to solve several problems, and I'm going to show you what happens when p is different values and d is different than 4. So we'll just kind of make them general. All right, so the point is I don't know what it's doing. I don't know if it's going to slide or stick or what. And so what I'm going to do is I'm going to make a table of assumptions, just like I've taught before. So the first thing I'm going to do is list the assumptions and then the degree of freedom based on those assumptions. First thing is there's no motion. That might happen, that I'm not pushing hard enough. If that happens, then I have 0 degree of freedom. Another one would be that it slides, but no tip. Doesn't tip over, just slides. If that's what's happening, the degree of freedom is 1. It's possible that it does not have it doesn't slide, but it does tip. If it tips without sliding, in other words, it sticks at point B, maybe there's bubble gum or something stuck there at B, and it just I push hard enough, it flips over. So there, the degree of freedom is 1. The last thing that could happen is it slides and tips at the same time, and so that would be 2 degrees of freedom. Alright, so what I teach is to start with the minimum degree of freedom. It's this one here, and then prove that it either works or doesn't work. So what I'm going to do is, this is a free body diagram problem, so I'm going to draw a free body diagram of this thing, and I'm going to try to draw it in general terms. Alright, so here's the free body diagram. I have a possible force here. I'm going to call it B. That'll be the pressure of the normal force. A. If it is no motion, then I don't know how much the friction is. All I know is it's less than or equal to mu Sn. So I'm going to label this as friction B, and then friction A. I have the weight of the guy down, which is 150. And then I have this force P, and it is a distance of, we'll call it D, and I'll just change the value of D to show different things. Okay, so now what I want to do is I want to write the summation of forces for this, and because I'm assuming there's no motion, there's no acceleration. So we'll sum forces horizontally. Right is going to be positive, and up is positive. And counterclockwise is positive, like I normally do. And so let's sum forces in the horizontal. P minus FA minus FB equals 0 because there's no acceleration horizontally. Vertically, I have A plus B minus 150 equals 0. And then summation of moments around the center of mass. I have FB times 3.5. That'll be a positive. Excuse me, that's a negative, because it would tend to rotating clockwise. Negative. I also have a minus 3.5 FA. I have a positive B times 1, and I have a negative A times 1, and then I have that force P, so I have P times his moment arm is going to be D minus 3.5, and that would be in the negative. And all of that is equal to 0 because there's no angular acceleration either. Okay, so here's what I'm going to do. I'm going to solve these things. right now I don't know FA, I don't know FB, I don't know A, and I don't know B. So I have 4 unknowns but only 3 equations. It's going to turn out that that I will not be able to solve for FA and FB by themselves. I can only get the sum total of them. So that's what I'm going to do. So what I'm going to solve for then is I find out from the first equation that FA plus FB, in other words, the total friction is equal to P. Right? From the second equation, I have A plus B, the total pressures are equal to 150. And then if I wanted to, I could solve for that last equation. I don't really want to at this point. But what I'm going to do is I'm going to say, okay, what else do I know? Well, I know that friction, the total friction, had better be less than or equal to mu s times the total normal force. Right, so in other words, I don't know how much is under B and I don't know how much is under A, but together the total amount has to be less than the static friction times the total values. Okay, so what I can do then is I can check my assumption. I want to know, is this true? Well, the total friction is equal to P, so I'm asking, is P less than or equal to 150 mu s? Well, let's see. What's 150 times mu s? Mu s is equal to 0.2. So this guy here is equal to 30. So the question is P less than 30? Less than or equal to 30? Well, if it is, if P is less than 30, the thing is not going to slide. If P is the 35, like in the problem statement, then it will slide. Okay, so that's how I've checked my assumption. So if your P is 35, like in the problem statement, then this thing is false. But as long as you push less than 30, then you're right, it will not slide. What you would also want to do is make sure that it didn't tip. But if any one thing is false, then they're all false. How would you know if it tips? Well, the only way you'll know if it tips is you'll solve for the pressure under A. And if A is negative, that means that the floor has to be pulling A down in order to keep it from tipping. So if this is not true, or if this is true, if A has to be negative, then you would say it tips. So that's how you would check that assumption. Okay, so let's say, okay, at 35, I know it's sliding. I know it's not this one. So I'm going to cross this one out. It's not that. So what do I do next? Well, I think it might be, it's either slips and no tipping, or else it's no slipping and tipping. So take your pick, flip a coin, decide which one you're going to do. I'm going to do this one here, mainly because I can see that for sure I know that the friction has been overcome. So I know it. I get a pretty good feeling that it's going to slide and not tip. Anyway, so let's go ahead and do it. Is the free body diagram the same? Well, the only difference, really, they're all the same, but since I now assume that it's sliding, this thing is equal to mu k times the normal pressure, mu k b. This guy here is same as it was before, but it's a mu k a. All right, the equations are basically the same. The only difference is, let's put them in blue. This guy here is mu k a. This one is mu k b. And then similar down here. So this is going to become mu k b. And this one is a mu k a. Now, because I am not solving for the friction forces, I better know what direction they go, and I think it's pretty obvious that they both go back to the left. Okay, so what are the unknowns here? Well, the unknowns are A, let's see, A, there we go, A, B, Okay. So I know it's sliding, so I sum forces in the horizontal, and this is equal to mass times the acceleration horizontally, because now it's sliding is what I'm assuming. This rotation is still 0 because I'm assuming it's not tipping. So the unknowns are capital A, capital B, and the acceleration A. So I have 3 unknowns and 3 equations. So I'm going to try and solve these guys. And in fact, I'm going to go over to Mathematica. So I'm going to pause this and pull up Mathematica. Okay, so hopefully everything still is being recorded. I'm doing a Mathematica, so I like to quit. Let me see if I can zoom in a little bit so it's easier to see. Let's see, maybe I can make this window a little bigger. Let's see. There we go. All right, so I'm going to type in the equations that you hopefully can see on the right-hand side. So equations are, there's going to be P minus mu k, I'll just call it mk, A minus mu k b equals, and this is going to be the mass times the, I call it ACC for acceleration. And then for the vertical, I have minus mu k times mu k b times 3.5 minus mu k a times 3.5 plus 1 times b minus 1 times a minus p times d minus 3.5 close bracket or close parenthesis equals 0. Let's see. Oh, I missed the middle one. Okay. That was the moment equation. All right, so the middle equation, that would be a minus f, a. Okay. It would be positive a plus b minus 150 equals 0. And let's see, I'm going to hit execute. All right, so here we go. Now, what are the things I know? I know that the mass is equal to 150 divided by 32.2. Let's see, what else do I know? I know that P is, mu k is, yeah, let me scroll back over here and see, mu k is 1.15. Mu k is 0.15. The D is 4 in the problem, if you want to do what's there. The P is 35. I believe I got them all. And you know what? Yeah, okay. 35. And then what I want to do is I want to solve the equations, and I want to solve them for A, B, the acceleration. We'll hit enter. All right, so what did I do wrong? Oh, AB, ACC, acceleration, ACC. Boom. All right, EQ. Okay. Oh, no. All right, let me pause this and see if I can figure out what I'm doing wrong. Okay, I don't know what I was doing wrong, but things seem to be okay. I'm just going to go ahead and re-execute this. So I'm going to quit. Here are the equations. I didn't change anything. And then let me just make sure that it, yeah, see, so it's kind of crazy. I don't know what I've done here. I'm going to pause it. Well, this is crazy. All I did was I re-executed the equation, And so now it's printing the equations. I don't know why. So I'm going to define the variables and then solve for the values. And so here's the results that I have. Okay, so the assumption that I made was that it was sliding with no tip. If it's not tipping, then the force under the leg A should be a positive number, meaning it still has some pressure there. And so it looks like that everything works out, that it is in fact sliding and it is not tipping. But here's what I want to do. Let's go back, and so that would be the end of it. So let me write down the answers over here. So A is equal to 26.8. B, pressure under that leg, is equal to 123, and the acceleration is equal to 2.68. It's positive, so it does in fact go to the right like I expected. Okay, so let's just kind of change things and see what would happen. So I'm going to let D be a lot larger than 4. I don't know what number to use. Let's say 6, so he pushes it a little higher up. So it should have more of a tendency to tip over. So I'm going to use that value, and he's pushing up a little higher. Now, what you can see here is that the normal force under A is actually a -8. What this means is if it is not going to tip like my assumption, then A has to actually be pulling down with 8 pounds. Clearly the floor can't pull down on the leg, and so therefore the thing is tipping. That's how I would know that this assumption of slip and no tip is either true or false. So if D was equal to 6 like this, then what I would do is I'd come in and go to the 2 degree of freedom situation where I know he's tipping, and I'd solve that one. We haven't gotten to the point of solving the bodies when they are rotating, so I'm going to leave that to the next section. But hopefully you can see how to make assumptions and make these things work. Okay, so I'm going to save this. I'll upload it along with the video and also the Mathematica file that goes along with it.